Howdy, this is the group of Chris Allison, William Knox, and Emilia Axworthy, and this is our dilution video.
Before you touch any lab equipment, it is important to make sure that you are wearing appropriate lab attire, such as having tied up hair and goggles and gloves.
A meniscus is the curved surface which forms at the top of a liquid in a small and narrow container. This occurs thanks to most liquids, like water, clinging to the walls of the container. This creates adhesive forces that pull some of the liquid up while the rest drops. In order to properly read the volume, you must measure from the very bottom of the meniscus.
The stock solution is the solution with the highest concentration that will be used to create our dilutions. This is expressed through the dilution equation, which is specifically used to calculate the concentration of a solution after it is diluted with the stock solution. Here, M initial and V initial represents the molarity and the volume that we start with, and M final and V final represents the molarity and volume we end with. To further represent this, here's an example of how we use the dilution equation in our experiment. We first started with the initial molarity, which was 0.02 molar, and we're attempting to find the volume needed to get a concentration of 0.01. After completing calculations, we found that we needed 12.5 milliliters of stock solution to mix with our solvent to have a final concentration of 0.01 in our dilution.
Once the first solution and equations are set up for the dilutions, start by using the primed pipette to quantitatively transfer a small portion of stock solution to the 25 milliliter volumetric flask, based on the results from the dilutions equation we went over earlier. Adding water until the meniscus sits just on the line. Then, place the cap of the flask on and mix the dilutions before transferring it to a clean beaker. Repeat these steps for each dilution, making sure to write a new equation based on the prior dilution to get the measurement needed for the next. After completing the 3 dilutions, fill the 6 cuvettes, making sure there is one blank, one with the stock solution, and one with the unknown. Then fill the last 3 with the dilutions. After returning with the absorbance values from the spectrophotometer room and putting another glove on to replace the discarded one, do the final calculations and properly clean the lab space, making sure that the bench is completely clear.